Okay, well, hello everyone and welcome. Jupyter Community Calls, they're back, yay. So happy November 2017. So the first thing I wanted to share really quick, I have a little right here, yes. Share that, just doing some slides. Oh, can I get sharing permissions or do I need to? There, does that work? Awesome, thank you. I made some quick slides just so I remember what to say every time. Welcome, this is November 17th. We're here, it's a community call and I'm super happy to have them back and it's great to see everyone showing up, so thank you so much. I did want to bring up, there we go. Community calls are recorded for anyone who doesn't know. If you don't want to be recorded, sorry, we're going to do that so that we can share them with more of our community. And thank you to everyone who's willing to be here anyway and present. Also, we do follow a code of conduct at Jupyter. I think people probably know this, but I also think it's worth bringing up at the start of calls. So here we go. It can always be found at jupyter.org/conduct. And we're going to get started. So today I'm super lucky. I managed to get 3 presenters. I need to stop sharing my screen. Do we start with shout outs said, or do we just do them on the agenda? Does anyone have thoughts on that?
We should say this one.
Okay, well, thank you.
Shout out to Isabella for reviving the Jupyter community calls.
Thank you. We're gonna do our best to make them so that other people can do them really easy in the future. So awesome. Thank you so much. I appreciate the thought. And first item on the agenda then, getting into it, we have a share from, I believe it's Nick, with IPyElk 2.0. So I'm happy, take it away. You ready?
Yeah, let's do it. I'm gonna get my share on.
All the kids with hats better hold on to them.
That's right. All right, something's probably happening. Hi all, this is a little tool we've been putting together. It's up on GitHub, it's up on Counterforge, it's up on PyPy, it's up on NPM because we have to publish in 50 places. The basic motivation behind IPyElk is being to lay out large graphs that have complicated relationships to each other. So this guy right here is just a little screenshot, and I'll get into that demo in a sec. But you can see, I've got a lot of layers of nesting. I've got different kinds of gazintas and gazoutas. Maybe got some interactivity and some custom animations that I want to do. And I want all those things to be interactive and responsive. So we started down this road. We tried some other things first, Site Escape, did some stuff with Data Shader, and they just weren't doing it for us. So we embarked on this quest on some money up at Georgia Tech. So I'm just going to jump right into the money one. This is a graph that I'm creating in NetworkX. I'm overloading a bunch of attributes, and we can watch it start doing stuff. And we got some data that's driving a chart. We got a data that's driving this interactive graph. Things go into and come out of the graph. Edges disappear when they can no longer occur. And it's a terrible, terrible ecosystem because, much like in Game of Thrones, where the ghost grass will consume all other life forms, eventually the grass just wins. You just watch those wolves. They're not lucky enough, and eventually they'll die. So we've got normal stuff in here that you would put in a simulation. So I can turn off this, and I can crank the speed all the way down. And I guarantee that the ghost grass will win. Turn that back on. There we go. And then the ground is covered in grass. You can see how it plays out here. So these are the kinds of things that we build for folks. Simulations, surrogate models, maybe stuff that's up on the HPC pipe. And we needed some pretty things that gave us some power towards it. Some of the other things that we do are in my examples, which I could have done smartly through my notebook view without having to leave single interactive. The really basic stuff is you can load in their particular flavor of JSON, which is from the Eclipse project. It's quite simple, it is nested, and we had some issues with that, so we had to make some other choices. We don't support everything that it supports because it supports everything because it is the entire graph layout mechanism. But you know, you get your interactive control of it, plays nice with output widgets, and you know, so these are the sharing the same model, so that when I hover, they're getting the same thing, but they're different viewports. We don't have you know, what is visible in how many viewports or things like that, but we'll probably get there. So all that viewport stuff is controllable from the animation, so we can fit all the way down to, you know, just something we got there. We can fit to just kernel. We can select stuff interactively. So now if I click here, you can see that that's getting updated. So we got some of the nice things. Yeah, we can automatically select kernel. We can select multiple things. So I leave my command keyboard in there. And we can clear things out. We know when things are hovered. Root is a thing, which is actually kind of nice to know when it's being hovered. And you can also set that programmatically. So we can crank it up right to, you know, they link together. That's not entirely surprising. You can do some fun things with changing the viewport. You know, so anything that I click on here, that's going to hover to, or that's going to highlight to over there. There's some stuff that's really hard to make with their JSON, so we made a higher ordered thing on top of it called the app, which is a bad name, but here we are. And it supports things like calculating how to collapse nodes, and it makes power edges out of things that it finds there. So come on. So we can collapse stuff down. So this gets really important for us. We're building sometimes things with you know, thousands of nodes if you want to expand everything, but maybe the important story can be told a little bit easier. And we've got some, you know, we can put some icons in there instead of that. Make custom close button, array ASCII art, you know, so we can close this, toggle collapse, close the button. Yay, we closed it. But then what we saw in that other example is we can do really aggressive styles to different parts of it. And it's still pretty raw. You kind of got to know what you're doing, you know, so we got stuff that only happens when something is collapsed. You can indicate that there's a collapsed edge there, and you kind of got to dig around through the DOM. So we're going to be working on some stencils and things to do that. You can also set it a little bit more Pythonically. So this is just some examples that it can apply to there. We have Svg exporting, so that's pretty fun. A browser does have to be in the loop, which is tiresome, but here we are. So, you know, if I open this in the new window, it embeds all the SVG. You get everything. You can't do subsets. You can't do a lot of things. It does, for whatever reason, bring along the selection state, so you can actually highlight stuff like that. So that's kind of fun. I'd love to have a way that this worked entirely offline, but we're not up to that task yet. Yeah, that's really about it. There's a lot of other complexity inside of here that we needed for some different kinds of tools. But the performance is good enough for our use case. We can crank it to about 1,000 some nodes with, you know, twice that number of ports and edges between them, and it kind of does the job. And then the only other exciting thing, oh, it's going to break in binder because I didn't put my X11 headers in there. God. Let's at least see it break. We've been trying to not do a lot of heavy unit tests and whatnot. So most of this is all driven by, I don't have it in here. I don't have the interact thing. Most of this is driven by acceptance tests that we do against the browser. So, you know, all those little activities that you saw up on there, we're slowly adding the rigor to make sure that that stuff keeps working. And that's really important for us because we go to the effort of shipping something and then it breaks for us immediately downstream. We don't really have time for that. So there's a bunch of robot stuff that we use to take care of that. That's about it. Any questions?
I think we actually have a few in the chat.
Nice. I will look at the chat. So this is iPad widgets and Hall views. There are no Hall views. There is no BQ plot. Are the examples tested? Yes. What do you need to know to use ELK, Network X? And yes, there's import NB. So those are those examples. And those were all very leading points that Tony threw in there because he's kind of a jerk like that. But yeah, I mean, we got CI. We use Do It to manage all of it because it is, on like a bunch of different buses. We do use Conda to install everything because there's a lot going on. Really the key build step is I'm not logged in, so I can't see what those logs are, but it really just fires up our Dodo Pi, and it does a monstrous amount of things. There's a lot going on here, but it works and it helps us release software, so I don't care. And it helps us when we step away from it for a while, and to know that it's just going to keep working. The JLab output area, do you identify any other ways to interact with the JLab infrastructure? When writing widgets, I try and have, unless they're very special widgets, I try and make sure that they don't do anything, special, because then they probably won't work in NBViewer or on Voila or whatever. So I can't think of a way that Elk would want to use Lab, but I can think of a lot of ways that Lab would want to use Elk. So if we got it to a MIME renderer at some point that took all these GGAWs and what's it and whatnot, it'd work in there. The other kind of weird thing, anybody that's played in the debug adapter space or the language server space, under the hood, we actually have an in-browser implementation of what is called the diagram server. So we just didn't want to run Node so that you could do these things. So the actual rendering could be done on a server. This is all we had to do to implement their fake stuff, right? But that actually could be very powerful in the long run. So long running jobs, give me a graph of that. Installation procedures, environments, all those kinds of things. We have some issues open for kind of things that we're interested in. Yeah, right here for the dog food. So yeah, source code, it'd be great. I just throw up a tree of my whole project and I can jump to where the file is. That sounds fun. Architecture diagrams, we need those everywhere in Jupyter. How does my GitHub Actions work? How do my automation processes work? What do I have installed? Show me some profile stuff. I mean, I've been doing these graph things for, on and off for years. So we've been thinking about a lot of this stuff, but we don't have any of it really spun up yet. Yeah.
I think you have one more question from Zach. Is there a standard data spec for network data?
There's so many to choose from. If you ever go look into the NetworkX read write, that is true. So the things that you find in there. So, it's graph links one. If you ever did D3, right, that's what you always find in there. And why'd you find them in there? Because they came out of NetworkX, or whatever. That particular lineage is lost to time. Cytoscape JSON is valuable. This Elk JSON is kind of a second-class citizen to their Java implementation. So whatever. And that is not currently supported by NetworkX, but that would be a really sweet PR if we had a better way to run this in Python and not only in the browser. Yeah, I mean, like we've done work with RDF and turning it into those formats and a bunch of other things. I mean, once you say network graph, like everybody's network graph looks very different, right? Is it nested? Is it not nested? And so I wish there was, and then I could just pipe all this stuff through this into Cytoscape, pipe this into GraphViz, pipe this into whatever, but yeah, whatever. We're 50 years in the hole on trying to make that happen. I see no other chats. I stop share. All right, thank you.
That was wonderful. Thank you so much for sharing that. Do people have more questions? Okay. Well, in that case, I think we'll go to our next share, which I happen to know is Tony with DGAF. So take it away, Tony.
It's the jerk's turn, apparently. Thanks, Nick. Let's see. What am I going to do here? Not the, I broke the demo this morning, but I'm going to share the intent of this work. So DGAF is the Deathbed's generalized automation framework. And the idea behind it is that it should be easier, simpler to use your Python tools within different environments, whether that be a local development environment, a GitHub action, or a Jupyter Hub, for example. And I think a lot of us have a lot of ideas, and it gets really hard to manage projects at scale. And some people are better at it than others. So I think that there's an opportunity to build a lot of publishing content from partial information in repositories here. So the Deathbed Generalized Automation Framework goes and does some of these things for us. So it does inference. So let's say you had a bunch of markdown content and some notebooks in there. What we're going to do is we're going to go and discover the dependencies that you reference, and then we'll build your requirements file, we'll build your PyProject file, we'll build your content environment, and then you can use these things on the different services. When we think about installing things, I work locally in Conda, but when I'm deploying to GitHub Actions, I'm working in a pit place. So using environment variables and files that exist, we should be able to manage how environments are installed easier. We should be able to develop and install stuff easier, and having a higher level API over top of the tool churn that's happening in Python, specifically on these, is really important. And then we should just be able to test stuff. We should be able to generate docs, and I'm doing this with JupyterBook, and JupyterBook's awesome. I love doing that. I love using JupyterBook for this part. And then we have post build. This should actually be binder now, but the idea behind this is that when we go to a binder, binder recognizes our post build file, and what we'd want to do is we'd want to just do DGAF build me a binder, and that would go and infer your environment. It would update your content environment. It'll go and install your setup tools or install your PyProject. But it should be, I think binder becomes a little bit more interesting of a utility if right now we've proven that we can do reproducible work on binder. But if we can go further and say, hey, what if binder actually set up as a development environment, and now somebody can go and use it and do development like things and actually potentially make changes and figure out how to upstream them afterwards. So we've got our post-build phase here. And the idea is that we want to build off of partial information. So for example, if we were to start with a PyProject TOML like this, it's got some extra entry points and stuff like that, but it doesn't have the key names that we need to generate stuff. So if I go over into a CLI here, this is very unbecoming. And we look at Git right now. Let me revert this file for the sake of the demo. And then where'd my console go? All right, there it is. Okay, good. All right, so now if we go and do DGAF infer, that's a superfluous output. We updated our PyProject here, and now it's updated, and this will work under a flit install, and that's a nice feature. It used to generate a conda environment. I must have broken that along the way, but oh no, there's a conda environment. Conda environments are generated, and it actually goes and does a solve in the middle with conda, and then it allows it to split it up with the pip dependencies and the conda dependencies here. And there's some nice mapping tools the depth finder has that lets me stay updated with these things. Yeah, this is not a good environment right now. I've got to fix something clearly. But then, so some partial information. And then when we go to something like GitHub Actions, what we would do is we would do our pre-install. This installs our environment. We do our install. This builds our package. And then we go and run our test. And without having too much opinion and only applying generating configuration files, we can do a lot with a little bit. So that's DJF. And one last thing is I am very happy with how I've written it. And even this is new to Nick, and we talked about this last night. But DGAF is running a lot of shell commands. So first of all, this is our README file here. And we've got some imports and we've got some all saying these are the things that are coming out of it. Then we've got our infer function, and that is going and reading our dependencies and creating our requirements when needed. And it's got some flags and some logic here. But then what's fun is when we get down to things that are actually running shell commands, this document is written in a literate form that uses conch also. So basically, this actually works as my code, and we can see some more fun shell commands here. But this is still a work in progress. It's just an idea. If anybody has any feedback, I'd love to hear it. And the business sort of happens here in, so Nick had import MB in his demo. This is an overloaded version of import MB that actually lets me go and import the README markdown document with the conch syntax and the hybrid IPython syntax in there. And I actually am like DGAF is a literate program. So that's kind of enabled by Tingle. I'll put some links in the HackMD, but I'm just going to stop. And those were some of the things I've been thinking about.
Thank you so much. I know you said it's a work in progress, but have you been able to solve your initial problem with that?
Yes, several times until I break it intermediately, and then I solve it again. But yeah, DJF's at the point where it's almost working on GitHub Actions. It works on Binder. It works locally. So like short-term goals, it's getting really close, and then hopefully adding more opinions to it.
That's awesome.
Thank you.
Does anyone else have questions, comments? Okay. I forgot to post the agenda in the chat, so I just did that. Sorry about that, everyone, if you were looking for it. It was hiding on the Discourse post all along. But we actually have one more share today from Eric, and I'm super excited to hear this one. What is a Jovian, Eric? Ready to take it away?
Yeah, this is exactly my question. I don't know what a Jovian is. The first time I've seen that word is when I launched a Docker container with the notebook. I connected to the container, and my surprise was, oh, I'm not root, I'm not Ubuntu, I'm Jovian. And I typed Jovian in Google, and it was not an existing word. I don't think it is. So I've been driven to some GitHub issues or Stack Overflow questions, and also to the Jupyter main documentation, I think. So this is a link I have put there. And it looks like, and this is my share, it looks like we are all Jovian, but who are we actually? And in the Jupyter ecosystem, sometimes you see IT people, sometimes you see PhD people, sometimes you see designer and so on. So it's very, very diverse. So this was my share, I guess. And if you didn't know what Jovian was, so you know at least it is some user of the Jupyter ecosystem, something like that.
I know there's been kind of a history with the use of that. Not that I'm super aware of it, but do other people have to weigh in on Jovian specifically? I don't know if I know enough to speak on it. Oh, go ahead, Darian.
I mean, just to be clear, it's meant to be a pun, right? So Jovian is the Latin adjectival form of or related to Jupiter. So like by Jove is a phrase you've probably heard, it means by Jupiter. And so switching that I to a Y makes it Jupiter E. But that's it, in case you didn't realize that.
And I think we've always encouraged and been really happy with the puns and plays with around the planet name, right? In the sense that the original motivation behind the name was actually a conversation and a quote around Julia, Python, and R being the three open languages of data science that inspired the name, not meant as an acronym, but meant as an inspiration. But there was always the connection to Galileo from day one, and to his discovery of the moons of Jupiter, and to the notion both of the scientists who builds their own tools, but also the long-running connection to astronomy in the scientific Python community. Astronomers were some of the earliest adopters of Python. The astronomy community has been very open to sort of tool building in science rather than only doing science, and giving the people who build the tools sort of respect and recognition, partly because obviously astronomy can't be done without building telescopes and building big complicated tools. So there's multiple threads, both in the history of science and in the history of Python and the SciPy community, and folks like Perry Greenfield at the Space Telescope, whose work funded early developments of Matplotlib and early developments of NumArray, which led to NumPy. So there's kind of multiple reasons why we have these connections, and that naming pattern has picked up a lot of momentum. Some of you may have seen the Syzygy project in Canada, for example, to offer Jupyter-based resources to on HPC infrastructure in Canada. So while Syzygy is a planetary analogy, planetary term, the Callisto project, also in Canada, to offer K through 12 educational resources in Jupyter, again, is a name kind of drawn from this. And it's kind of fun to see that intersection of naming puns around the history of astronomy and our place in the solar system and whatnot. And people find ways to use the Y sort of misspelling in to give them a twist and to make them. Now, the downside is sometimes you can't find these things. The good side is they have basically a disjoint search space, right? Which was very handy when we were establishing the Jupyter name in the community. Like, well, you know what? That word actually doesn't exist. And so there's a nice and clean, in a world that is overcrowded with overlapping names, and it's hard to find a unique term that isn't sounds like incomprehensible gibberish to anyone. This actually ended up working quite well for us. So that's a little bit of sort of long-running commentary from the early days of the name.
That was awesome. Thank you. That was way more info than I had. I also know people have played with like the character Joe, right? Like that astronaut a little bit. Yeah, there's Zach, I know. Like Joe the Jovian. I don't know. I see it very rarely, but I have heard about it some, which is another playful thing. We have some playful comments too in the side, like jovial Joe.
That's all Tony, man.
I've got some original Joe drawing right here. Actually, this was like after, I don't know, what was it, Nick? JupyterCon 2018 or so? We were talking about Joe afterwards.
We were walking back to my weird Catholic hostel and just talking about like how it was Matthias's idea. He's like, we need a mascot because I'm tired of people using the Jupyter trademarked logo that we have to maintain and protect or we lose. We needed a toy, we needed a figure that could be used very flexibly. And we were talking about like, that's really hard because what does a Jovian do? And who is a Jovian? What do they look like? And we ended up with this space person, space robot, space monkey, space whatever that could hide inside of those things and do all these fun things. Yeah. Oh, anyways.
That's a really cool idea though. And that's a good point from Matthias too, right? Working with that.
I want Joe to be the new Clippy. I'm just saying.
Lofty goals, Tony.
I don't know if anybody else does.
So that is actually what we have on the agenda for today, and it went faster than I thought it would. But yeah, we can continue discussion on any of those. If anybody has anything that they want to show totally off the cuff, there's never any pressure with these about, I don't know, how formal they should be. We just love to have people share. So if there's anything people want to throw in the ring here.
I can throw something in there. I'm gonna off the cuff something. I love that. Thank you for doing this. I like yelling at people. If anybody wants to leave, go ahead. But there's this line of code that I want to show you all. All right, so I'm just going to run this. And I should return me a data frame here. Oh, I don't have pandas? That's crazy. I got a new mini conda the other day. And man, all right, import pandas. Now okay, great. Oh, that's why. Import pandas. It actually needs pandas there. All right, DF. So now what this is here, if we go to workflow runs, I didn't know this part of the GitHub API existed until recently. Pandas.series. So now this gives us a data frame. And what this is the GitHub API returning you information about your GitHub actions and your workflow runs. So like conclusion, it was a failure. What's the status? So you'll actually get information about intermediate runs while they're still going on. It's got date time information. There are links to log files and stuff like that. So this is just a pretty interesting trove of data that I wasn't aware of. So basically the form of the endpoint here is your repos, and then your organization, your project actions, and then runs. And it gives you all of the workflow runs that have happened. I think it's up to 100, but you can paginate through that. And yeah, I thought some folks might be interested in this if they're doing a lot of build work and want to introspect it at some point ever. So that was my very, very quick demo here.
How did you find that?
It's not in the GitHub API specification. I don't remember. I just dug around. I found it on Google search somewhere. But it's good data. It's pretty cool data, especially if you can just dump it into some like graph or diagnostics and export an artifact or something. It's kind of a nice tool.
Have you been using it so far, I guess, then, is the next question?
No, I found out about it yesterday.
Oh, yesterday.
I used it one time. I just demoed it, and I'm not sure if it worked or not.
That's awesome. I love that. I love that demo energy. Thank you so much for sharing that then. Yeah. Great. Well, I don't want to keep everyone if there's not further discussion to be had. A few wrap-up things. First, I do want to thank everyone for being here because I really wasn't expecting this many people at all, to be honest with you, or this many shares. So thank you, and thank you for the enthusiasm. I hope we can keep carrying it on. Next month call is December 15th. That is on the calendar, but I will be promoting it again. And if you're interested in presenting, I think I'm just going back to throwing it on the agenda because that's what people did anyway. So I will make that appropriate discourse comment and the agenda will be on there. And yeah, if you have any interest in sharing things in the future, please do. As you saw here, right, doesn't have to be whatever you think, polished, technical, anything that you would expect here. I think anything involved in the Jupyter ecosystem would be awesome to hear about. And yeah, thank you so much.
Isabella, do you have an exit form?
I do, but I need to throw it. Is the chat the best place to throw it?
Let's put it in the chat, and let's also put it in the HackMD.
Okay.
So we can keep making the computer. It would be really nice if y'all could give us some feedback about how today went. Yeah, that would be helpful.
2 questions too, so, or 4 maybe.
Simple.
Yeah, no pressure,
Simple.
but thank you so much.
Awesome. Thank you so much for doing this.
Yeah.
And looking forward to the next one.
Thank you so much, Isabella. This is fantastic, and I really appreciate it. I was didn't realize that the community call was happening today. It's my bad. I had lost track of it, and I sort of hopped onto the governance documentation work. But this was the best surprise of the day. So this was wonderful, and I really, really appreciate what you folks are doing. This is wonderful.
Yeah, thank you. I heard that might happen, even though I was told and it was an open slot. It seems like I was wrong somehow.
No, it's
thank
totally
you for
fine.
playing along. Yeah.
No, it's totally fun. It's totally cool, and it was useful for us and informational and whatnot. So no, this is absolutely wonderful.
Thank you.
Hey, Fernando, can we convince you to give us a community Christmas gift and you do a live demo next time?
Yeah, for sure. I should have something from class or something.
That would be awesome.
That would be amazing.
Awesome.
I want to see
my holidays.
I want to see IPython 2002 or 2001. That's what the demo I want to see.
Oh, that actually exists. One thing that could be cool would be to demo. I put it up online a while back. I made a copy. I need to find it because I don't remember where it is, but it's up on GitHub somewhere. The very first weekend that Brian and I got together to basically to split up IPython into a client and a server, which was really the nugget that got us going with the communications protocol, and then implementing the proper kernel and server that led to the Qt console, and then that led to building the notebook and like the modern Jupyter architecture. That was a little hacking exercise at Brian's place in March 2010. I just drove down for a weekend to his place in San Luis Obispo. And what we did was, it was kind of cool because we were hacking. This was using 0MQ. Brian had just written up Python bindings for it, so we could use it in Python. And we didn't use IPython proper. We just wrote a teeny client and a teeny server, and we were working actually off of two laptops. So it was neat that we were implementing the client server tests and the protocol by actually one of us running the client on their laptop and the other one running the server. And it was kind of neat. If we were playing with something on the client side, we would keep like killing it, making edits and restarting it, but leaving the server up on the other laptop, and just like it would reconnect, and 0MQ was seamless. So it was a really fun experience to play with that. And the code is lying around. So one thing we could do is look at the old IPython and look at this like baby micro prototype of what became IPython and what became the Jupyter architecture. They're both on. I have them both up on GitHub somewhere, so I could dig them up and we could play a little bit with it and take a trip down memory lane.
That would be awesome.
Yeah, it should be fun. But Isabella, thank you again so much. It's wonderful to see this energy piping into the community. And there were many new faces and names for me today, which I was really delighted to meet. You included, Isabella. So it's very nice meeting you.
Nice to meet you too. Thank you. Yeah, thank you so much, everyone, for being here. Really, it means a lot to me. And I think it means a lot to the community to stay connected. So thank you. And I will see you in a month. Hopefully.
Thank you.
Have a lovely rest of your day.
Bye,
Whoever is recording, don't remember to stop the recording.
That's what I was